Okay, Algebra, we've got Chapter 9, Section 4. We're going to look at overlapping events, a little bit different than what we looked at previously. So what we looked at last week were called mutually exclusive events, and we didn't discuss that a whole lot, but we're going to at this point. So if we have a mutually exclusive event, that means that it has no common outcomes. And so while last week we might have been selecting a candy bar or something like that, there were still multiple candy bars or multiple sweaters or multiple marbles that we could choose from. In an overlapping event, we will have common outcomes. Because of that, they're going to use the word or in this section. So maybe if I have a deck of cards and I have to find a queen or a red card. Well, we know that there are queens that are red, so those are common outcomes that would overlap. So let's take a look at a deck of cards. So we've got 52 cards, and we're actually going to look at an example that's in the book. It's on page 434, example number 1. And so it's going to ask us to find what's the probability that the card is a 10 or a face card. So probability that it's a 10 or face card. So now let's think about that. So if we have 4 suits in the deck, we have hearts, we have diamonds, we have spades, and we have clubs, and each one of them has a 10. So that means out of the 52 cards, 4 of them are 10s. Now let's think of face cards. Face cards are jacks, queens, and kings. Remembering that we have 4 different suits, so there are 4 jacks, 4 queens, and 4 kings. So that gives us a total of 12 out of 52. And so since we're using or because they overlap, instead of last week where we multiplied, this week we're going to add those events together. And so that's going to give me 16 out of 52. Now, some of you may have asked, well, why didn't you reduce that before you added them together? Well, they already have a common denominator. And so if I can take that opportunity to just add together, and now I can reduce from here, then that might save me a little step in the long run. And when this reduces, it reduces to 4/13. So the probability out of a standard 52 card deck that you pull a card that is a 10 or a face card is 4 out of 13. Okay, so let me rewind on this one. I kind of skipped a step. This is actually a disjointed probability. Okay, this is a disjointed. What that means is the 10s and the face cards are not the same. There are no 10s that are face cards, and there are no face cards that are 10s. And so the next one I'm going to do is a true overlapping. And so we have 52 cards again. Again, this is going to be an overlapping where we will have some that would satisfy both events. And so this is example number 2, just after that one, and it comes to the top of page 435. So in this one, what's the probability that it is a face card or a spade. So probability that it's a face, I'm just going to put face. I shouldn't do that. I'm going to put face card. Or a spade. So we need our two. We need to know how many are face cards out of 52 and how many are spades out of 52. So just like the one we did before, we know we have 12 face cards. So 12 out of 52. And then just recalling from last week, from doing 4 suits in a deck, so that is going to be 13 spades. Now, the question here is, how many face cards are spades? And so in a true overlapping event, we will have to subtract the ones that meet both requirements. So if I have spades, I have 3 face cards, a jack, a queen, and a king that are spades. So 3 out of those 52 meet both requirements. So I'm going to subtract the amount that meets both requirements. So again, I'm not going to do any reducing because these already have a common denominator. And I'm going to go with 12 plus 13 gives me 25. And then I have 25 minus 3. That's going to give me 22 out of 52. Now I can reduce that to be 11/26. Okay, so one more time. 12 out of 52 are face cards. 13 out of 52 are spades. And 3 out of 52 are the spade face cards, or face cards that are spades, however you want to look at that. So add the two probabilities and then subtract the event that occurs both times. So we're about 7.5 minutes. That is Chapter 9, Section 4, Overlapping Events.